So there's also what's called centroid effect. So in this case, you have a relatively impermeable, low permeability shale, and inside of the shale, you have some tilted sand formation. And because in the sand, which is relatively well connected, right, in the sand you'll have what follows basically a near hydrostatic pressure gradient. So if you notice, here's the hydrostatic line. This line represents the gradient in the sand. It's near hydrostatic because it's well connected. But the shale is not as steep. It's near lithospheric, right? So it's near the overburden pressure. So then this, in the shale, you have a gradient like that. So the point where they meet is called the centroid, and anything above that is going to be in an overpressure or a higher pressure. So in other words, the sand is going to be at a higher pressure than the surrounding shale. And this is really a big deal in drilling because if we're drilling along and we're in shale, and then we go into this, we understand the pressure in the shale, and then we tap into the top of the tilted sand, then all of a sudden we have a much higher formation pressure. And if we don't adjust the mud weight quickly, I mean, have you guys had a drilling course yet? Okay. So if you don't adjust the mud weight associated with that, then you'll have reservoir fluids coming into the wellbore, and if that's not quickly under control, then you can have a blowout.